So, hello students. Today we are going to discuss very important model for JEE Main and NEET in electrostatics. Most important model. This is a big calculation problem. So, first of all, read the problem. Two identical positive charges, capital Q each, are fixed apart at a distance 2a. A point charge small q lies midway between the fixed charges. Then show that number 1, for small displacements along the line joining fixed charges, the charge q execute SHM if it is positive. If it is positive. Number 2, for small lateral displacement, it execute SHM if it is negative. So, in these two cases, compare the frequencies of oscillations in two cases. Compare the frequencies of oscillations in two cases. So, this is our problem. So, very this problem is very important model. So, please listen carefully. Here, two identical positive charges. These are the two identical positive charges. Identical positive charges. They are separated by how much distance? They are separated by 2a distance. Now let us discuss first case. A point charge q lies midway between the fixed charge. In the first case, that point charge is placed midway between this fixed charge, that is positive. That is a positive charge. If this charge is displaced along the line joining fixed charges, it execute SHM. So, now we are going to calculate time period of this particle, this charged particle. Okay. Now, this is displacement up to small displacement x. Okay, give the numbers. This is the first charge, and this is the second charge, and this is the third charge, and this charged particle is displaced towards left, towards the first charge. Then here, how many forces are acting on this charged particle? So, due to this charged particle, there is a repulsion force is acting. Repulsion force is acting. Due to this charged particle, there is a repulsion force is acting. For example, if this charge is moving towards the second charge, then there is a repulsion force is acting. That force is along the direction of left. So, this is how much here, total distance to a, the distance from first charge to center charge a, the distance from center charge to second charge a. So, here the distance between first charge to third charge, this is the third charge, a minus x. The distance between the second charge to third charge, that is equal to a plus x. A plus x. Now, we are going to calculate force acting on this third charge due to first charge. That means F31. F31. What type of force is acting? For example, if this charge is moving towards first charge, then there is a repulsion force is acting. That repulsion force is along this direction. Okay, that is equal to 1 by 4 pi epsilon naught q into small q divided by a minus x whole square. Equation 1. A minus x, the distance between the capital Q and the small q towards the right side. Right. Now the force is acting on this charged particle 3 due to the second charge. That means if this charged particle is moving towards the second charge, then what happens? This second charge repels this charge. So there is a force is acting on the third charge. Force acting on the third charge due to second charge along this direction, leftward direction. Right. That is F3 2 is equal to 1 by 4 pi epsilon naught, again q into small q divided by, what is the distance between this charge and this charge? A plus x. A plus x whole square. Equation 2. Equation 2. Right. Now, which force is greater here? Which force is greater? Clearly F31. The distance here is less. Clearly we understand that F31 is greater than F32. F31 is greater than F32. Right. So net resultant force Fr is equal to F31 minus F32. Okay. Right. Fr is equal to substitute these values. F31 1 by 4 pi epsilon naught q into small q divided by a minus x whole square minus F32 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught q into small q divided by a plus x whole square. A plus x whole square. So here F resultant is equal to here what we take common, we take common 1 by 4 pi epsilon naught q into small q, take the common. Now what we get here? 1 by a minus x whole square minus 1 by a plus x whole square. Right. F resultant is equal to 1 by 4 pi epsilon naught q into q. Right. Take LCM. Here a square minus b square whole square. A square minus x square whole square. Here what we get here? A plus x whole square minus a minus x whole square. Okay. Right. Now let us continue this problem from this end. So Fr is equal to 1 by 4 pi epsilon naught q into q. Do you know formula? A plus b whole square minus a minus b whole square. What we get here? A plus b whole square 4ab. That means 4 a x divided by, okay, a square minus x square whole square. Compare a and x. A is the distance of charge, first charge, from mid position. X is the small displacement of a charge small q from in position. So here clearly a greater than x. A greater than x. That means by comparing with x, by comparing with a, x can be neglected. So here that means a is greater than x. That means x can be neglected. So Fr is equal to 1 by 4 pi epsilon naught q into q. Here what we get here, 4ax divided by 4ax divided by a to the power of 4. So F resultant is equal to 1 by 4 pi epsilon naught q into q, 4x divided by aq, 4x divided by aq. Right. Here we know that acceleration of this charged particle, resultant force by m, mass of the particle, r is equal to f bar by m. So a is equal to Fr 1 by 4 pi epsilon naught q into q, 4x divided by whole divided by m. Already here a cube is there, m k a cube. Third step, f resultant by m. So here what we cancel here, 4 cancel, 4 cancel. What is the acceleration of a particle in SHM? This is we put as 3. But acceleration, general equation for the acceleration of the charged particle is a is equal to minus omega square into x. X is the displacement. A is equal to minus omega square into x. This is equation how much? 4. So compare this equation. Compare this equation. What we get here? Omega square is equal to, in the place of omega square, what here? What is the present here? Omega square is equal to capital Q and capital Q, small q divided by pi epsilon naught m a q. Pi epsilon naught m a q. This is nothing but capital Q. You got 4 cancel. 4 cancel. Now let us do this problem here. Here. So here omega is equal to square root of q, capital Q into small q divided by pi epsilon naught m a q. Okay, right. We know that omega is equal to how much? Omega is equal to 2 pi by t. Omega is equal to 2 pi by t. That is equal to square root of q into small q divided by pi epsilon naught m a q. Okay, right. Now t is equal to what we get? So t is equal to 2 pi square root of pi epsilon naught m a cube divided by capital Q into small q. Capital Q into small q. This is the expression for a time period. This is the expression for a time period of a charged particle when it is displaced along the axis. This is the equation. This is the time period t1. Put this equation as 1. Right. Next. Now let us discuss case 2. Let us discuss case 2. Here, what is the case 2 here? Case 2. For small lateral displacement. So, for small lateral displacement, it execute SHM. If it is negative. Then we find out time period of the charged particle. For example, so these are the charged particles, Q, capital Q. Now this is displaced laterally, that means perpendicular to the line joining between the two charges, like this. Here, what is the charge here? Negative charge. If it is negative charge. Okay, this is the total distance to A, and this is A, and this is A. Right. Now in this case also, this negative charge execute SHM. How? Now we are going to discuss about that. Right. This is the 1, this is the 2, this is the third charged particle. Okay. What are the forces acting on this third charged particle? Force due to 1. That means attraction force. This is F31. And force due to this charge, that is attraction force, that is also F32. So here what is the F31 here? F31, force acting on third charge due to the first charge, is equal to 1 by 4 pi epsilon naught q into small q divided by, this is equal to square root of a square plus x square. This is right angle triangle. Let us assume this is theta and this is theta. Okay, that means here this is a square plus x square, equation 1. Now F32 is equal to 1 by 4 pi epsilon naught q into q divided by, this is distance, same distance. How much distance it is? Square root of a square plus x square, Coulomb's law. That root is cancelled according to Coulomb's law. A square plus x square, equation how much? 2. Okay, that means these are the equal forces. So these are the equal forces acting on this negative charge in different directions. So exactly this is nothing but what? Resultant force. This is resultant force. Resultant force is acting towards mean position, and this bisects these two forces. Okay, that means here the displacement is upward and resultant force is downward towards mean position. That means force and displacement are in opposite directions. They are proportional. So this charged particle execute SHM, and this charged particle comes towards again mean position. Right. Now, so if this is 2 theta and this is theta and this is theta, why? Because this resultant force bisects. These are the equal forces. Okay, and here F31 is equal to F32. That is equal, let us assume F. That means this is F. and this is also F, right. Now this can be resolved into two components. This F can be resolved into two components. This is F cos theta, this is F sin theta, this is F sin theta, this is also a F sin theta, and here this is F cos theta. So component of this one is F cos theta along down this direction. Component of F32, that is also F cos theta along this direction. That means F resultant is equal to what we get here, 2F cos theta, 2F cos theta, 2F cos theta, right. F resultant is equal to 2 into, here what is F here? F is nothing but how much? 1 by 4 pi epsilon naught q into small q divided by a square plus x square. Okay, and what is cos theta here? Cos theta adjacent side by hypotenuse, that means x by square root of how much? A square plus x square, right. F resultant is equal to, what we get here? So 2 into 1 by 4 pi epsilon naught q into x divided by a square plus x square whole power how much? 3 by 2. Okay, now let us assume A is equal, acceleration of the particle is equal to resultant force divided by m, so A is equal to, what is the resultant force here? 2 q x divided by 4 pi epsilon naught m a square plus x square over 3 by 2. Now compare A and x. Here A is greater than x, so x can be neglected. So if we x neglected, what we get here? Acceleration is equal to 2q x divided by here 4 pi epsilon naught m a q, right, m a q. That means here omega square is equal to, we know that general equation for SHM is equal to how much? General equation for SHM is equal to omega square into x. Okay, now compare, this is equation 3 and this is equation 4. Compare these equations. Omega square is equal to 2q divided by 4 pi epsilon naught m a q, 2 1s are 2 2s are. Okay, now here omega square is equal to, here omega square is equal to, what we get here? Q, small q divided by 2 pi epsilon naught m a q. Omega is equal to square root of q, small q, 2 pi epsilon naught m a q. What is omega here? 2 pi by t. In the previous case we assume as time period as t1. Now we assume this time period is t2 is equal to q divided by 2 pi epsilon naught mk. Now t2 is equal to time period of this particle, 2 pi square root of 2 pi epsilon naught maq divided by capital Q into small q. Okay, this is the expression for the time period. In the case of negative charge is placed in between the two positive charges and it is displaced laterally, right. Now compare these two time periods. So already we got here t1 is equal to t1 by t2. T1 by T2 is equal to, yet this is T1, 2 pi square root of pi epsilon naught MAQ by capital into small divided by T2 is equal to, this is T2, 2 pi square root of 2 pi epsilon naught MAQ divided by Q into Q. T1 by T2 is equal to, what are cancelled here? Cancel items, QQ. Okay, that is equal to what we get here, 1 by root 2. 1 by root 2. That means T2 by T1 is equal to root 2. T2 by T1 is equal to root 2. We know that time period is inversely proportional to frequency. That means F1 by F2. F1 by F2 is equal to root 2, that is equal to T2 by T1. This is the ratio of the frequencies of charged particles in two cases. Very, very, very important. This is the most important in JEE main model and NEET also, but heavy lengthy calculations. Okay.